So we're going to be on lesson 4-2 today. Oops. And we're going to talk about functions. And today's date is 2/17. So if you notice that some of our graphs either went linear, we could draw a line out of them, or some of them was just kind of scattered all around. A function, there needs to be a certain relationship that takes place with those ordered pairs. So this is the definition of a function. So a function is a relation. So again, there's ordered pairs that somehow belong to each other, where each domain value, that's your x-coordinate, has exactly one range value. And that would be your y value. Okay. So you cannot have a domain value, an x value, that has two different y values. So having two ordered pairs where you have 3, 5 and 3, 7. It won't work. That's still a relation, but it's not a function. Okay? So that's one thing that we're going to be working on today. All right? Is that notion. So what we're going to do is we're now going to change, because our functions generally are going to be rules. And those rules are going to tell us how to come up with a function. So a function looks just like an equation, to be honest with you. So this is what we were used to seeing as a linear equation. And all we're going to do to change from looking like a linear equation to a function is we're going to change the y value. Each function has, a letter that represents the name of that function. Most functions are represented by the letter f, f for function. Then it tells me what variable my rule is listed at. So first change, or the only change really, is instead of y, we say f at x. That's how we read that. Okay. So let's describe what this means. So this is called the function. So if I read this, the function of x So now this tells us this is going to be a very special kind of relation, that I'm only going to get one y value for each of my x values. Okay. Now, I can have a repeater y value as long as it doesn't match up with the same x value. So I can repeat my y's, but I can't have an x pair up with two different y's. That would not work. So that's just called a function of x. Now, basically how a function works is you put something into this function, this machine, and out comes something. Okay? It's an input-output system. We called this f of x part that took the place of y, he's called the output. Okay? This is called the input, is the x part. That's just the x. It's what I put into my function machine. And this entire thing is called the function rule. It's what happens when you have a number and you stick it into this function machine. It applies this rule and it kicks out an output number that matches your input number. So basically, we put in an X value, it kicks out a Y value. We create an ordered pair, we can graph it. Okay? So one of the things we didn't do when we were talking about equations and graphing them is we never really came up with a table of values. So this is when we use this idea of a function rule, is when we put in X values and then stick them into the rule, come up with the output, and then we have ordered pairs to graph. Okay? That's what you were practicing with your relation, was taking these ordered pairs, graphing them. Now we're going to go a step further, and you got to actually figure out what the ordered pairs are. Okay? Now this only works for functions. Okay? And the functions have the rule. So what we're going to be using is what's called a function table. So again, not the kind of table that we eat off of, but it's a chart, so to speak. And in the function table, what you're going to do is you're going to organize the input values, which are your x's, the rule, which looks like an equation, and output values. Which are your y's. Okay? So a function table is just a way to organize your data. So let's talk about the x and the y in the chart. They have special names, and I've actually talked about these names before, but now we're officially going to write them in our notes. Okay, by the way, what's another name for input or x values that you talked about yesterday? It's the domain. Good. And then what would be another name for the output values or y values? Range. Okay. So all those words that you talked about yesterday still work with this. Okay. So let's talk about the x values. Your x values, which are also your input values, which are also your domain, are called the independent variable. And the reason why it's independent is it can be anything you choose. You can pick that, or it may be given to you, but it can be any number, okay? Anything can go in there. So it's independent because it can be any value. So this is the hard part, is that kids will like, well, what numbers am I supposed to pick? And the answer is anything you want. Now today I'm going to actually give you, if you look on the board there for your homework, I'm going to tell you specific input values to choose, because that way we can grade our homework. Because if I said you can pick anything you want, then I couldn't grade your homework, because everybody could come up with different x values and therefore get different output values that goes with those outputs. So that's why we're all going to have the same thing together. So your book may not have all the answers because, again, there's a million choices. Now, the y values, which are also called the output, which are also called the range, they're not independent. They're not whatever I pick them to be. They are the result of sticking an x value into the function rule and cranking out a number. Okay? So they're the result of doing math. So they're called the dependent variable. And they're called the dependent variable because it depends upon the x/domain value. Okay, so the answer that I get for the y depends upon the number x I put in. So I choose the x's, that's my independent choice. But once I make that choice, I stick it into the rule and there's one answer that comes out. So that one answer depends upon what number I put in. Okay, so independent versus dependent. All right, let's see what else I want to say. That's pretty much all that you guys are going to be working on. Okay, so let's talk about some examples of various things you're going to see on your homework tonight. Okay, everybody good? So if you want to do the examples on the other side, that's fine. If you want to put them there, you may not get them all done on that same page, because I see most of you are about 2/3 of the way, halfway to 2/3 of the way done with that page. So let's talk about two different things that you're going to be asked to do. First is going to be find the value of the function with the given input value. So if I want to find the value of the function with the given input value, means I want to know what the output value is. I'm giving you the number to put in. I want you to tell me what you get when you take the number out. So you're going to see something that'll look like this. Find the value of the function at -3. So what they're telling you is, remember how we wrote the function was f at x? If, now here's my function and the rule are going to come up now. They said your function f, written in the terms of the variable x, the rule is I'm going to take x, double it, and add 1 to it. That's what 2x plus 1 tells us to do. So what you notice is that they both start with f, then come parentheses, which leads us to understand that that -3 is just saying this is what I want your x value to be. This is what I want you to put into your machine. Okay? So all we're going to do is replace x every time we see it with -3. So our function now becomes function at -3. Equals 2, and then times -3. So every time I see x, I just replace it with -3 plus 1. So then we just do the math. The function at -3 is equal to -6 plus 1. The function at -3 is equal to -6 plus 1 is -5. So I write my answer as this equation, or this statement. The value of the function f at -3 is -5. And that's all I need to write, is the outcome. What did my function look like? Well, it had a -3 in for the x. What did I get out? I got the -5. Okay? So let's try another one. Let's see. I need you to find the value of the function at 2 if the function at x equals x minus 4. So the only thing that I do is every time I see f or x, what am I going to put in its place?
2.
I'm going to put in 2. So f at 2 equals 2 minus 4. That's the only thing I'm doing here. So my answer, the value of the function at 2 equals -2. And that's, I'm done. Okay? So I want you guys to try this third one on your own. Find the function at 11 if, of course I'm going to give you a tricky one. Here, I'll write it below here. if the function at x is equal to 1/2 x plus 5. All right, so all we're going to do is replace x with 11. So we get the function at 11 is equal to half of 11, which would be 5.5 or 5.5. Add 5 to that, and we get 10.5. Okay, that's it. So let's talk about, the last example is what do they mean by this function table, and what are we going to do with that? So the directions are going to say, it's going to ask you to choose 4 values for x and make a function table. And then they're going to give you a function. So ours we're going to work with is f of x equals x plus 5. And then you're going to state domain and range. Nope. So how we do our table is it looks like this. We're going to choose our x value. X represents domain. Next, we're going to have the rule. And the rule is going to be f of x equals x plus 5. So we're actually going to do work in the middle column. Then we have y, or actually we'll do it this way. We won't do y, we'll do f of x. That's the output, so that's your range. And because we want to come up with uniform answers, we're all going to pick the same x's every time they ask you to do this, unless they give you the x's. We're going to pick -1, 0, 1, 2. So what we're going to do is here, every time I see x, we're going to plug in -1. So I'm only going to write it this way once. And what's -1 plus 5? 4. Okay? So now I'm going to plug in 0 for x. And 0 plus 5 is 5. And now I'm going to plug in 1 for x. And 1 plus 5 is 6. And now I'm going to plug in 2 for x, and I get 2 plus 5 is 7. So what's the domain? What's the domain? -1, 0, 1, 2. That's what we put in, and we're all going to choose the same. What's the range?
4, 5, 6, 7.
Yeah, it's what we got in our output column, in our f of x column. And that's the second part that you're going to work on for homework tonight. Okay? So that's what page 291, 293 is all about.